I would like to introduce our first speaker of the day. Mark Trostler is a O'Reilly author, well respected in the community. He's written a book on Testable JavaScript. He was born in SoCo, that's short term for Southern California. He says he's going to live there till he dies. I told him please don't do that anytime soon. And with that, I'm going to hand it off to Mark. And so here you go.
Thanks. I don't know about well respected in the field. I don't know where that came from, but. Okay, so my name is Mark. I work at Google. I'm an SET with Google Help. I'm actually based in Irvine. Yes, I have this book, Testable JavaScript. O'Reilly was supposed to send out a bunch of copies, but they failed. So they said, find me afterwards, and I'll collect emails. And if you're interested in the book, I can get you a free e-copy. OK, so when we talk about testability, actually, before I even jump into this, we've heard a lot about testing and automating your testing. And I think Simon yesterday said something really great, which was you can't sort of bake in testing and maintainability and all this stuff after the fact. It needs to be there from the very beginning. Otherwise, you're not going to get the benefits of automation and easy testing and all this. So it's really important that from the very beginning, your applications don't just come in at the end and try to test something. Really try to be present at the beginning when these applications are being developed and architected, so you could have your say about how maybe they should be built to make your jobs and our jobs much easier down the line when you need to test these things. OK, so when we talk about testability, these are sort of the standard things that get thrown out. We want loose coupling and tightly focused methods and all this other good stuff, no surprises and all that. And I hear these and I see these in a lot of presentations and when I talk to people. And that's great, and I don't think anyone disagrees with any of these things. But rarely do we talk about, OK, how specifically do we actually achieve these things? What do we need to do our applications to actually have loose coupling and tightly focused methods and all this other good stuff? So the way we get there is using interfaces and not implementations. And what I mean by that is, and what a lot of this presentation is about, is we talk a lot. There's a lot of talk, especially in the JavaScript community and probably in Java as well, about hiding data. I want to make this private. I want to make this protected. I'm going to use the module pattern or closure to hide variables or properties and methods from you. And when you start talking about what you're hiding versus what you're exposing, I think you've sort of already lost. And so what I mean by that is when you program and you test to implement to interfaces and not implementations, your life becomes a lot simpler. You can swap implementations very easily. You could work and test and code all in parallel. And we'll see what I mean by when I say all this stuff. And you could write the test one time, hopefully, and then as you implement different functionality, your tests don't have to change or change very little. Okay, I don't know. We have some bonus slides that have slipped in here, so I'm just going to ignore this. So when I talk about interfaces in JavaScript, the first reaction is, well, JavaScript doesn't have interfaces. Well, it sort of does, and we could fake it by creating an object like this and defining a bunch of empty functions or methods. And when I do this, what I've done here is essentially I've created an interface. Here's an interface for a user repository. It provides all the basic functionality that I need to get and set and deal with users. Everyone's application, most applications have users. You need a way to store them somewhere, somehow, and then retrieve them back later. So here we create a simple interface that could get and set and query and do these other interesting things to a user repository. And what's great when I have an interface like this, besides the fact that it's very sort of self-documenting, is when I write my tests, I write tests to the interface. So here you could see I'm passing in a repo object. I don't care what this repo object, how it's actually implemented. I just care about its interface, the save, and the get methods. So I'm going to write a test here that I'm going to save a user, and then I'm going to call get and get the user back, and then I'm just going to verify that the user I saved was actually the user I returned. And this is all via the interface, not via some implementation that is buried somewhere in the object. So now when I want to actually have an implementation of that interface in JavaScript, it looks something like this. First, I have a constructor function, which takes parameters specific to that implementation. So here I'm using the Redis data store to implement the user repo interface. And it takes some host port options, sort of injected, as we'll see, dependencies into the constructor. And then I have I have my Redis client here. And then later on, I set the prototype of this constructor function to be the interface itself. So here I'm sort of declaring to the world that I am going to implement this user repo interface. And then finally, on the prototype, I then go ahead and define all the methods that the interface says I need to define. Get, save, query, delete, whatever. So in this way, I've sort of created a JavaScript object that implements my interface. So what we've got here is we have an object that's acting as an interface. There's no initialization you could do on this object. This object can only be used by implementations to actually get work done. The interface itself does nothing. The implementation itself has a constructor which takes specific parameters that are injected into it to actually create the object, the implementation. And then I sort of state my intention to the world that, hey, I'm going to implement this interface by setting my prototype equal to it. And then finally, in the actual implementation object, I then go ahead and I override all those interface methods. And now I have an actual implementation of that interface. And what's great here is now when I need to test this thing, I've already got the tests. I just create a new object of this specific implementation of the user repo interface. And now I just call the test method on it. And great, I do my save and my get, and hopefully it all works. And now I've just tested my implementation. So time goes on. My application is growing. Redis turns out, oh, crap, that was a bad idea to use Redis. We actually really need to use Amazon S3. No problem. Very simple. All we need is a new implementation of our user repo interface. I'm going to call this one user repo S3. Has a constructor. It takes parameters that are injected into the constructor for what we need for this specific implementation. I'm going to announce to the world that I am also going to implement this user repo interface. And then I'm going to go ahead and actually create the methods that actually are going to implement that interface, the save, the get, the whatever. Hey, I've already got the test for this thing. All I need to do is wire up a new Amazon, user repo S3 object, run it through my test that I've already created, and I could tell easily, quickly, if this thing actually works or not. Which brings us to our first principle of the day, which is the single responsibility principle that says every interface essentially should just do one thing and one thing only. Which leads us to the second principle of the day, which is no object should be forced to depend on methods and functionality that it doesn't use or need. And we saw that in our user repo interface. It just deals with saving and getting users. There's nothing else in there. There's no extra functionality that I might or might not need later. Which finally takes us to our first pattern, which I'll just call it the interface pattern here. When we bring all this stuff together, we have the single responsibility principle. We match sets with gets. And what I mean by that is if your interface has a way to take something in, it should have a corresponding method to get the thing back out. I see this a lot with logging. There's a method on the logger to log something, and then it goes away, and there's no way to get it back. The only way to get it back later is you have some other way to maybe query the database later to actually read the logs. That's sort of dumb. You should have something in the interface. If you could set it, you should be able to get it back. You end up with more smaller interfaces versus a couple really big interfaces that try to do everything. You really want a lot of small, focused ones. And then, of course, we want the interface segregation principle. We want our interfaces just doing one thing only, not any extra functionality in there. And when you write tests, and when you write your application, you just look at the interface. You don't look at the implementation. That interface we saw, the user repo interface, it's an object. It's self-documenting. Here are all the methods on it. Here's sort of what the parameters they take. That's the only thing you should be looking at when you're programming and when you're testing. OK, so we've created a bunch of nice interfaces. We've maybe got some implementations of those interfaces. Now it's time to actually use this stuff. What we don't want to do is just turn around and in something that actually needs our user repo is to call new. Because what we've done here is you've tightly coupled your implementation to the thing that needs it. So here later on, when I switch from Redis to S3, I need to go through all my code and find out all the places where I've sort of got this user repo Redis object that is now very tightly coupled here and replace it with the S3 object. And not only that, any parameters that this thing needed to be created, I need to somehow switch to now being the S3 parameters instead of these. So we don't want to do this. This is the sort of the definition poster child of tight coupling when you do something like this. So what you do want to do is pass the dependent in the constructor, just like we saw for those interfaces earlier when we were creating implementations. You pass these things into the constructor. And then later on, we just sort of save off a copy of it. And then later on, this class will use the interface methods of this user repo object. And now, my user controller doesn't care, doesn't know, doesn't want to know whether it's Redis, it's S3, it's MySQL, it's whatever the heck you decide it should be later, because these things will change, and they do. This class does not care, doesn't know. It's just programming to the interface. Which brings us to our next principle, the Liskov substitution principle. It has a really big, impressive-sounding name for something that's pretty obvious intuitively, which is any object that implements the same interfaces, they can be swapped out at will. So as we saw earlier, I have my user repo S3. I have my user repo Redis. I could swap them out to my user controller class. My user controller class has no idea, doesn't care, shouldn't have to know, doesn't know. That's all thanks to the Liskov substitution principle. A great phrase. So when you pass in all your dependents to a constructor, you end up with something called constructor injection, a very fancy name for just passing in all your dependents to the constructor. And what's great about constructor injection is it makes all of that object's dependencies very explicit, such that you can't even create this object until you have all of its dependencies passed into it. You can't create an object that's sort of half created, and then later on you need to remember to call like an init method or set something else up over here. You can't even get this object at all until you've actually passed in all of its dependencies in the constructor. This also gives us this nice loose coupling that everyone agrees is a great idea. That lets us swap out implementations at runtime or whenever you need to, essentially, to get very loose coupling. There are a couple exceptions to this rule, and we're going to talk about those in a little bit, runtime dependencies being the most common. When we talk about constructor injection and we say you can't create an object until you pass in all of its dependencies to it, the first thing you would think about is, well, crap, that doesn't seem to help me. Now now I need to know all of the dependencies of any object I need in order to create that object. And that sort of puts all the onus on me, and that doesn't seem to make sense. Well, you're right. You shouldn't create objects. In fact, you should very rarely, if ever, create any objects during the normal course of the running of your application. What we want to do here is we want to create all of our objects up front at the very beginning of before your application even runs. Create all your objects, create all your dependencies, and then sort of kick your application off once you have all of your dependencies and all the objects created from this giant object graph. So what we've got here is we really have broke our application into two distinct phases, if you will. One is at the very beginning, at a place called composition root, if you want a fancy phrase for it. You create all the objects your application is going to need for its entire life. You sort of follow this object graph, and you create all these objects, and then you create sort of the highest level one, and then you kick it off and hit start, and then off it goes. So we create all of our objects at the very beginning, and then in the first phase, and then in phase 2, we actually use the objects and our application runs, and it's all great. Now, in a web application, composition root isn't necessarily when the entire application starts up, say with the web server or something like that. There's also the request cycle. For instance, a user object, you don't know who the user is specifically until the request cycle starts and you've sort of retrieved your session. You're like, oh, the user is Mark. I'm going to create the user object Mark that represents him. So it's OK for your composition root to be scoped at a request cycle as well as from the very first time your application starts up. OK, great. So we want to create all these objects at the very beginning. Well, then what creates all the objects? Well, there's lots of different dependency injectors or inversion of control containers, whatever you like calling them. Those are the things that are actually create your objects for you. And you could use sort of one off the shelf. Certainly there's many for Java. There's a lot for JavaScript as well, it turns out. Cujo.js provides wire.js is a really popular one. Do it yourself, that's a DIY, dependency injection. You could also do it yourself. And the idea is at the very beginning of your application at the composition root, whether that's during the request cycle or when your application first starts up or when you first push all your client-side JavaScript to your browser, you sort of say, this object depends on these three objects depend on these 8 depend on these 24. Finally, at the very bottom, you have a set of objects that don't depend on anything else. So you create those first. You walk your way up your sort of dependency graph till you get to the very top, and then you've created everything. And that's what these dependency injection or inversion of control containers are really good at, are walking that object graph to create all your objects for you. AngularJS, open source Google project, does dependency injection as well. So you have lots of options here of what you want to use. OK, so you've created these sort of self-contained objects, and they just do one thing, and they do one thing only, and that's great. And then the question is, well, what about this other stuff that I might want to do? I might want to do logging. I might want to do auditing, caching, all these sort of cross-cutting concerns. And the question is, how do we sort of weave these cross-cutting concerns into the fabric of our application here? We know we don't want to pollute our interfaces with logging or with any of this other stuff because you might need it, you might not need it. Not all classes might want logging. So how do we bring all this stuff together? Well, let's first look at what we don't want to do. And what we don't want to do is what we saw earlier, which is just sort of create new versions of this stuff within a specific implementation. So within my user repo Redis implementation, I don't want to just turn around and call new logger or new profiler. Again, this tightly couples us to those implementations. And it makes things a lot more difficult to test when you have this stuff sort of buried within the object itself. It's a lot harder to mock out and stub this stuff out. So you say, OK, well, I want to pass some stuff in maybe to the implementation. And this is on the right track in that we're using constructor injection. But there are a lot of problems with this approach as well. For one, the single responsibility principle here is now we have a specific implementation. User repo Redis is now sort of baked in logging and profiling. And when I want to use the user repo Redis object, and maybe I don't want profiling and I don't want logging, I'm sort of stuck here. So what I mean by that specifically is you'll end up with code something like this in your save method that's implementing the save interface method. You sort of put all this extra junk in here that not all users of this class might need. Here we've got logging, we have profiling, and then in the middle of all that, we're actually going to reach out to Redis to save the user. And then we're going to do some more logging and more profiling. And the problem here is, in our next implementation, user repo S3, I've got to remember if I want logging and profiling, I've got to pull all this code out of there, and I've got to put it over here. And as I said earlier, not everybody, you might not want logging and profiling all the time whenever you're using this object. So the solution to this problem is, like the solution to almost all problems, is we want to keep the different functionality separate. We want to maintain the single responsibility principle. We want to keep, we don't want to put in any extra functionality into our implementation here that some classes might not need. So what we want to do is create an interface. So here is a logger interface. You see it has just two methods here, a log method, and then, again, a way to get the log back out once you've put the log in. And here's a simple implementation of that interface. Here's an implementation that's going to log to a file. You can imagine one that would log to a database or log to a remote logging somewhere else. I have my implementation-specific constructor that's going to take a file. Here I'm announcing to the world that I am going to implement the logger interface. And then I go ahead and blow through all the interface methods and implement them for this specific implementation. So quick aside here, one thing that makes JavaScript really nice is we could sort of do whatever we want with the objects, a lot of sort of built-in reflection. Here's just a quick method called mixin, and what this method is going to do, and we'll see how we use it on the next slide, is we're going to sort of take all the methods from a base class and automatically end them so sort of from a base, and we're going to automatically add them to a different object. So we're just going to blow through all the properties in our base object, and then if we find one that's a method and that doesn't already exist in our current implementation, we're just going to stick it on the current object, and we'll see how we use this in a second. Well, let's just look at how we use this thing actually. OK, so let's get back to our initial problem here, which is we want to sort of have logging with our user repo. So here's how we do it. We create something called a decorator. And here's a specific implementation of a user repo logger. And the idea of the decorator here is it is going to also implement the user repo interface, but it's going to have logging baked into it. So again, here I have a constructor, which is being injected with its dependencies. In this case, it has a dependency of another user repo object. We don't care which one, because it's just we're just programming to the interface. And a logger object, again, we don't care which one, because we're just going to deal with the interface. Now we're going to mix in all of the original repo's original methods into this class. And this is really just sort of a helper, which lets me not have to define all of the save, the get, the query user, the delete user methods. if I don't declare any of those off our prototype, then they will just fall back to the sort of the inner repos version of those methods. And then finally, I actually am going to implement the save method here. And what I'm going to do here is I'm actually going to take the logger and I'm going to do my logging. And then I'm going to sort of hand off responsibility for the actual repo saving to whatever repo was passed into me. And so here what I've done is I've sort of intercepted or decorated the save method with logging. And what's great here is the inner repo, whichever one I happen to pass in, user repo Redis, user repo S3, or whatever, has no idea that logging is happening. And the logging has, no idea about the user repo. They're not mixed in any way, only through this decorator class. So when I want to create one of these things at the very beginning of my application, using my dependency injector or my container, I create whichever implementation of user repo I want, here in this case the Redis one. I create whichever implementation of the logging I want, here in this case the file one. And now I've got another user repo that, thanks to our good friend the Liskov substitution principle, says I can now use this user repo anywhere I was using a user repo before, and now I get logging for free without having to mess up my original user repo Redis or S3 implementations. OK, so we talked about we wanted to do profiling too. Remember that? So let's, again, go through this same kind of deal here. I'm going to create a profile interface. It does a start and a stop. And then, of course, it has a way to get it back out, too, once we've stuck it in. Here's a very simple implementation of that interface. Here's my constructor function, which has implementation-specific parameters, none in this case, announcing to the world that I'm going to implement the profile interface. And then finally, I'm going to go ahead and actually implement all of those methods there. Here's just start, stop. One can imagine, of course, other profiling. What if you wanted disk space profiling? What about if you wanted CPU profiling? No problem. Just create another implementation of the profiler interface, and you've got those. So again, I'm going to create another decorator for this one. I'm going to call it user repo profiler. This one, in its constructor function, takes, again, an inner repo. It takes a profiler interface. I'm going to mix in everything from the user repo into this current object. Again, this is just sort of like a convenience, so this object doesn't have to implement all of the interface methods if it doesn't want to. And then finally, I'm going to sort of intercept or decorate the save method of the user repo interface. And in this case, I'm going to start my profiler. Then I'm going to delegate to the inner repo to do any actual saving. And then I'm going to stop the profiler. So now I have a sort of a profiling user repo. And then finally, we're going to put the whole thing together here to get a all-seeing, all-knowing, all-doing, logging, and profiling user repo object. So first, I'm going to create a specific implementation here. I'm going to use the Redis one. And for grins, I'm going to use the time implementation for profiler. I'm going to use the the file implementation for logger. And now I'm going to sort of create here's my profiling user repo object. And then here's my logging profiling user repo object. Because I've been programming to interfaces, and because of our good friend the Liskov substitution principle, I can use this user repo prof object anywhere I can use a user repo object since it implements that interface. So I'm going to use that to pass into the user repo logger object. And now at the very end here, I have a user repo object that can be used anywhere a user repo object could be used. But this one has logging and profiling built into it. And at no point have I sort of violated any of our principles of keeping things separate. And what's great is I could test the heck out of my logger implementation. I could test the heck out of the profiler implementation. And I don't need to mix them. I don't need to have that kind of testing also when I'm just testing the user repo interface as well. OK. So just a quick note on tests here. There's a couple ways to test decorators. One is you sort of mock out the part that's doing the decorating. Then you just sort of call your save method on that object, and then you verify your mocked out object. The other way is to sort of create the whole thing and sort of mock out everything. And so this is more like if you don't trust the fact that when you put all this stuff together, it's actually going to work like you think it is, you could do tests like that. The previous way is you've sort of tested the two in all the interfaces in isolation, and you could just run them through your normal user repo test that we saw earlier, that save, that's just saving to the that's just using the interface methods. So they're really easy to test, and these decorators are very easy to mock out as well. Which brings us to our second pattern, which is the decorator pattern, which is what we just saw. And the whole game here is, again, everything we just saw. You create a constructor that sort of takes an inner version of the interface and any other objects it needs that it's going to decorate the interface with. Then you want to sort of mix in the inner objects methods into your decorator object, so you don't have to implement all the interface methods if you don't want to. And then finally, you go ahead and actually implement the interface methods that you want using the decorator, using the other object you passed in, the logger or the profiler, to actually do the work that you want the decorator to do. And I say in there optionally because it turns out you don't actually need to call the inner interface if for some reason your decorator decides it doesn't need to. And the canonical example here is caching. You don't want to build caching directly into your implementations. You could write a caching decorator that in the save method or in the get method, it would look to see, hey, is this object already in my cache that I'm keeping locally in the decorator? If so, I don't need to delegate it all to the inner repo. I could just return the object I've already got. OK. Last bit I'm going to talk about here is what about runtime dependencies? And so the example here is I've got a dating site, awesome website. People come, they try to find their matches for who they want to go out with. And there's a couple different criteria they could use to determine what they want to use to find their matches. They can use, do we share the same likes? Do we like to do the same activities? Distance, how far away are they from me? Or anything else you could think of. And the idea here is that when the user comes to the site, they sort of have a pull down, and it's up to them to select how they want to find their matches, one of those three things. Well, the thing is, you don't know what they're going to pick, right? So you can't sort of create a user controller object or something at the beginning with one of these find match algorithms because it's up to the user to pick it, and you don't know what it's going to be. So the first step here, of course, is to create an interface called find matches. This is given a user ID. It's going to return a set of matches for them. And then we're going to go ahead and create some implementations of this interface. Again, here's that F is just short for function because there wasn't enough room on the slide. So I have a constructor function here. Here's one for distance. Here I'm going to say I'm going to implement the find matches interface. And then I have some other objects here. I've got one for activities. I've got one that's going to find your closest matches for likes and whatnot. So here's the crux of the problem here is in my user controller, I don't know what you're going to pick. So I don't know which find match sort of implementation to inject here. So I could inject all three. That's clunky, doesn't smell right. What about if I come up with a fourth one later? Then I gotta make sure to add it there. What if there are other things that need sort of a dynamically injected find matches? So the solution here is an AbstractFactory. So I don't want to get too bogged down in the terminology AbstractFactory. That sounds crazy. That sounds like something you need in Java, not something you need in JavaScript. Isn't JavaScript supposed to free us from all of this? Well, when I say AbstractFactory, what all I'm talking about here is it's an object that's going to take a runtime value and return a dependency. That's all I mean here. So to create one of these AbstractFactories, just like everything else, I'm going to have an interface. I'm going to call this one findmatch_factory. It just has one method, getMatch implementation. And you can see it takes a type. And this type, say, is just a string likes or activities or distance. And it's going to return to me the implementation I need, the find match implementation I need to actually find the matches that the user has requested. So here's a quick implementation of this interface. Again, I have my constructor. In this case, it's going to take a user repo object. I'm here broadcasting to the world that I am going to implement the findmatch_factory interface. And then here is my getMatch implementation, actual implementation of it. And you can see there's something slightly strange here, which should make you sort of recoil, is that there's news in here. Whenever you see new in code, you should get a little bit scared. But it turns out for factories, it's OK. It's OK to call new here. This is the whole point of this object. You don't have to do it this way. You could also pass these sort of 3 or more implementations in via the constructor. It's sort of up to you how you want to do it. But the idea here is I'm going to take a type, a runtime value, and I'm going to return an actual implementation. So in this case, I'm going to switch on the type, and depending on which one they selected, I will return you the correct implementation for that type. OK, so what happens here is in my user controller, what I'm injecting into its constructor is the AbstractFactory. That's the whole game here. So here I'm injecting in the AbstractFactory. I save it off for later. And then, so here's the constructor. Here's I'm saying I am implementing the controller interface. And then in this method here, where that finally boils down to when the user has actually selected their type, I know what type they selected. I know what the user is. Now I reach out to my factory that was injected to me, and I say, aha, OK, I finally got the type. Give me the object that matches this type. It does. And then now I could call the interface method matches, if you remember from the find match interface, to actually get the matches that the user requested. So here I'll get it by distance or likes or activities or whatever they wanted. What's great about AbstractFactories is they're really easy to test. They're not doing very much, right? They're just translating from a type to an object. So a dead simple test is just to iterate over all the known types and make sure you got the object back that you expected. And they're really easy to mock out. So when we want to test this, the user controller, mocking out an AbstractFactory is really simple. So here's an implementation of our AbstractFactory for test. It has a specific constructor that takes a mocked out match version and what the expected type was. I say I'm going to implement this interface, and then the get matching implementation just sort of returns the mock, plus it checks to make sure that the type it got passed was what was actually expected. And then you can go ahead and inject this mocked out or test version of the AbstractFactory into your user controller. Which brings us to our final pattern of the day, which is the AbstractFactory pattern. And the game here is, as we just discussed, I'm going to take a runtime value, and I'm going to return to you an actual object for that runtime value. The factory implementation itself has created a composition root along with all the other objects. And you inject the factory instead of injecting the actual find matches object into the constructor of any object that needs to deal with this runtime value. And then finally, you use the factory at the moment when you actually need it to get the actual dependency that you needed. OK. So to sort of tie a bow on all this, what we really like to see when we're talking about testable JavaScript, or really testable probably anything, is we like composition. Inheritance is a little more stifling. Composition allows us to really easy mix and match pieces that we need without sort of sullying our implementation objects or our interfaces. We want to program and test to those interfaces. Again, I talked about at the very beginning, hiding data, making stuff private, putting like an underscore there to make sure people know that, hey, this is private, don't touch this. Using interfaces, it's just, here's the interface, that's what you got, that's it. You don't have to worry about hiding as much. Again, we want to create lots of small interfaces because we've seen how easy it is to mix and match them together. And it's significantly easier to test small interfaces and to mock out small interfaces than it is big, hairy, complex ones. We're going to decorate and intercept for those cross-cutting concerns. We're going to constructor inject all of our dependencies, even the runtime ones, using abstract factories. And again, here's our abstract factories for the runtime dependencies. And finally, there's really, unfortunately, only one way to actually ensure testability of your code, and that is to write the test first, because then you're guaranteed to have the tests up front. But if you follow all these patterns and these principles I showed you, maybe you could try to get away without writing the test first, but why would you want to do that? That's all I got. Thank you very much.
Yeah, thank you, Mark. That was fantastic. And thank you for bringing back my childhood fears with the Cujo JS. So for those of you that don't know Cujo, it was this giant German shepherd that's rabid, attacks his family. They're stuck in a car. Everybody dies. It's a terrible movie. So years of Beethoven and Disney has fixed this, but I'm going to have to watch some of that tonight. So
Sorry to take you back down that road.
OK, if you have questions, we have 2 mics in the aisle like we did yesterday. So I see one live question. When you ask your question, state your name, your company, and your question, or you can delete other parts if you don't really want to state your name. So with that, go ahead, please.
My name's Alec Monroe. I work at ArcNinety. I noticed one piece that wasn't injectable, the Redis client or the S3 client. Wouldn't that become an issue when you were trying to do something live and you didn't want to actually, or trying to test something and you didn't want to actually have to be talking to S3?
So yeah, that's a good point, because when I was looking at the slides, I was like, you could just inject the Redis object itself into your user Redis repo. But sort of the idea of the user Redis repo is it's talking to Redis. So that's sort of a piece of that object that can't really be abstracted away. But using the programming to the interface, it's really easy just to create a mock. So if you don't really want to talk to Redis, it's really easy just to create a mocked out version of user repo that is just checking to making sure, like, did I get this? Was that what I expected, and whatnot?
So use a different repo in that case.
Yeah, you just put it in a different repo. Since you're just programming to the interface, it doesn't matter what the implementation actually is.
With that, thank you. If you have other questions, I'm sure you'll be around, Mark.
Yeah, I'll be around. This is a good question on the Dory too, but maybe I can
Yeah, it's a fantastic question. It
Yeah.
says it's about performance concerns. If you have 10 seconds, 10 seconds. Here you go.
Yeah, 10 seconds. So the idea is so the question is, well, if you create all your objects up front, isn't that a performance problem or something like that? It turns out it's really not. Since you're going to be creating all these objects anyway during the course of your application, it's better to create them up front, and then you have less of a performance issue throughout the rest of your application.
Good answer. All right. Thank you. All right.